Okay, so in this video we are going to talk about electron dot diagrams, which are also known as Lewis diagrams. While studying covalent bonds, we have intuitively tried to use dot diagrams to gain an understanding of how covalent bonds are formed, how electrons are shared. But in this video we are going to undertake a little bit more formal study of dot diagrams, electron dot diagrams. So electron dot diagrams, as I told you, is also known as Lewis diagram. And when we draw electron dot diagrams, basically we are trying to only show the electrons in the valence shell. And as it says that the outer shell electrons are represented by dots around the symbol in a square arrangement. This thing is important here. We arrange electrons in a square arrangement, and these dots are arranged in twos if more than 4 outer electrons are present. So for example, if I have a element X and it has got 3 electrons in its valence shell, then I will show them unpaired here because they are only 3. But if another element Y has got 5 electrons in the valence shell, then I'll show them like this. I'll show start with 4 of them as single electrons, and the 5th electron I will show as pairing of one of those electrons. That way, what it's saying is that if there are more than 4 electrons, then you start pairing them up. One thing about these diagrams is that we are in fact looking at the octet rule, and octet rule says that whenever atoms are trying to make bonds, then they want to get a full octet in their valence shell. Now out of these electrons here, what we have is we got 2 different kind of electrons here. These single electrons, they are known as bonding electrons because these electrons are available for bonding. So these are known as bonding electrons, and the electrons which are already paired up, they are known as non-bonding electron or lone pairs. Non-bonding electrons or lone pairs. So in this element X here, we got 3 bonding electrons, which means that all these 3 electrons are available for pairing up by making bond, by sharing. Whereas in this element Y here, there is 1 lone pair, and these electrons, they are not available for making a bond, but it got 3 single electrons which are basically available for making bond by sharing. Let's look at a few examples. So let's look at nitrogen here. Nitrogen, we know that it has got 5 electrons in its outermost shell, in the valence shell. So 5 means we need to have 1 pair and 3 single electrons there. So these 2 electrons, this is a lone pair, and they are not available for bonding, whereas these 3 electrons, they are bonding electrons. Now I would suggest that we do some practice on these questions now. So here's a table, and I want you to pause the video. And try these questions, and they are basically really simple. I'll be doing the first one here, and then you can pause the video and do the remaining ones. So in carbon, we know that there are 4 electrons in the valence shell. So number of valence electrons is 4. Electron dot diagram, because there are 4 electrons, so we start with unpaired electrons, and that's what we have. If we had 1 more, then we start pairing them up. So this is the electron dot diagram of carbon. Number of lone pairs, we see that there is not even a single lone pair, and number of bonding electrons available is 4. Now I think it would be okay for you guys to pause the video and have a go at these 3 other elements. Okay, so once we do this we have talked about electron dot diagrams of atoms, but we have electron dot diagrams of molecules as well, and that's what we are going to look at now. So when we are trying to draw electron dot diagram of molecules, then we follow certain steps, but these steps here, they are really elementary and quite intuitive. If you look at them, will basically be going through one of the examples, and that will tell us more about how to draw electron dot diagrams of molecules. So first one obviously is that you draw the dot diagram of each of the atoms in the molecule, and in each of the atoms we normally look at the electrons which are available for bonding, available for sharing, and these we use for sharing and making covalent bond. Paired electrons, as we already discussed, do not participate in the bonding. The atom with the most bonding electrons is placed in the center with the other atoms bonded to it. So it would be fairly easy, fairly intuitive if you know what I'm talking about. And the only thing is that in the resulting diagram, all the electrons must be paired, and each atom except hydrogen must be surrounded by 8 electrons. So let's take one example first. The example that we got here is, we can start with say bromine. We'll take an example of bromine, and then we'll take one more example. We'll take an example of H2O, and others I would suggest that you try on your own. So bromine gas is Br2, and that's what you're looking at. So bromine it's a halogen which is in the 17th group, and it has 7 electrons in the valence shell. So 7 electrons. So we start with 1, 2, 3, 4, and then we start pairing them up. So there you go. I'll put that on the other side. So this is one atom of bromine. The other atom of bromine, we see that in this electron dot diagram, I see that we got 3 lone pairs here, and they are not available for sharing, but there's a single electron here which is available for sharing. And likewise we would have another one as well, and I will draw them with crosses. So that one also has got 7 electrons, and we see that both of them have 1 electron available for sharing. Maybe I should put them in the middle. So that's the one, this is the other one, and that's my bromine. So these 2 electrons in the middle, they are shared, and what we have is a bromine molecule. So that is electron dot diagram of bromine molecule. And if we want to write about, if we want to show that using a structural diagram, then that's what we have, bromine and bromine. The one is water. So let's take the case of water. Hydrogen has got only 1 electron, so that's 1 electron here, and oxygen has got 6 electrons in the valence shell. So we'll start with single atoms, and then we start pairing them up. So we got 6 electrons here. So we see that in oxygen there are 2 lone pairs and 2 single bonding electrons. So these lone pairs are not available for sharing, but these single electrons are available. So we need to, okay, so let's draw them again. So these 2 electrons are available for sharing, and because hydrogen only needs 1 electron, so each of these 2 electrons will be shared with 1 hydrogen atom. I can clean that up, and I can write here, and that way my condition is satisfied that oxygen has 8 electrons, oxygen has a full octet, and hydrogen has got 2 electrons. And that is all about these kind of simple electron dot diagrams of molecules. But if you look at, before we move any further, I just would suggest that you pause the video and try all these electron dot diagrams on your own in your exercise book. Okay, so these steps that we got for drawing electron dot diagrams may suffice for simple molecules, but if you have molecules which are a little bit tricky, then these steps are not going to work. We need to revise those rules. So let's take an example of carbon monoxide. So carbon monoxide, we look for carbon is, look at the electron configuration of carbon, electron dot diagrams. You got 4 there. Oxygen, we got 6. So these are there, and carbon monoxide, here we are trying to bond these two so that both of them get a full octet. And here we already see that carbon needs 4 electrons. Carbon has got 4 bonding electrons. So carbon can share 4 electrons, but oxygen on the other hand, it can only share 2 electrons. And this molecule does exist, so we have to somehow satisfy needs of carbon and oxygen both with one of those. I mean, one carbon atom and one oxygen atom, and they should share electrons and bond in such a way that both of them have 8 electrons in the valence shell. So these steps that we just saw here, they are not going to be useful here. So we have a different strategy, different method of writing these electron dot diagrams of these kind of molecules. That's what we are going to look at next. Okay, so let's look at these kind of molecule here. So these steps here, they may sound a bit tricky in the beginning, but we'll go through a couple of examples, and that will make things obvious and clear. So first thing we need to do is we need to find the total number of valence electrons in the molecule. So what we do is we find out the number of valence electrons of all the atoms, then add them. These many electrons we will need to show in our dot diagram. So whenever in the electron dot diagram, we are showing the valence electrons. So what we are doing here is we are finding total number of valence electrons that we need to show somewhere in our diagram. Right, so let's take the example of carbon monoxide. So carbon has got 4 valence electrons, oxygen has got 6 valence electrons. So that gives me total 10 valence electrons that I need to show in my diagram. Yeah, so is equals to 10. Somewhere I'll need to show these 10 electrons. Okay, if it is an ion we are drawing dot diagram for, then we'll need to adjust the total number of electrons found above. This is not an ion, so at this stage I will skip stage step number 2. Step number 3 says that draw the skeleton with the most electropositive atom at the center and connect them with a single bond. So I need to have 6 electrons, and what it is asking me is just draw a skeleton with a single pair of electrons shared. So that's a single bond there in between carbon and oxygen. Now out of these 10 electrons, we have already shown 2 electrons. We have already placed 2 electrons. We need to show 8 more electrons. So I start organizing these 8 electrons, and I will try to give one of these atoms a full octet here. So you got 2 already here. I'm going to do that for oxygen. So 2 electrons are already there. I need 6 more. So oxygen now already has got a full octet here, and out of 10 electrons I have used 8 electrons. Now I got 2 more electrons, and these 2 electrons I will place on my carbon. Okay, so far so good. Now I need to see whether all my atoms have full octet or not. So I see that oxygen has got full octet. I have used all my 10 electrons, and oxygen has got a full octet, but carbon has not. So what I need to do is, out of these electrons that oxygen has, they are shown as lone pairs here. I need to convert them into shared electrons, which means I need to bring them from here 2 in between there. Let me show what I'm going to do. I'll clean this thing up, clean that thing up. So many things have been cleaned. So this is my oxygen. Okay, so because my oxygen already got 8 electrons, but carbon has got only 4, so I need to give 4 more electrons to carbon. And what I do is these lone pairs on oxygen, I will move them from here and I will put them, those were lone pairs, and I converting them to shared pairs. I convert them into bonds. I still got 6 only, so I will convert that as well. When I'm moving this lone pair to make a shared pair here, it's not changing number of electrons available to the oxygen. It is still 8. When I'm moving from here to here, they still remain with oxygen. Only effect is that they also get counted for carbon as well. So clean that up, and sorry, so these 2 electrons, I clean them as well, and I convert them into, from here I put them here in the middle so that they are shared electrons. So what I've done is I have converted 2 lone pairs which I had on oxygen in the beginning into shared pairs between carbon and oxygen. And now I see that I got 8 electrons for carbon and I got 8 electrons for oxygen, and I got 10 electrons. So this is my electron dot diagram for carbon monoxide, and if I want to draw it, show structural diagram, then this is what my carbon monoxide would look like. Some people, when do this, they also show the lone pair available on both the atoms. This is what your carbon monoxide would look like. Okay, let's look at another example, and this time we'll take a look at the iron. So we'll look at carbonate ion. So carbonate ion is CO3 2 minus. So first step, let's count valence electrons. Total number of valence electrons that I need to show are carbon has got 4 plus each oxygen has got 6. So this will be 3 times 6 equals to 18. So that gives me 22 electrons that I need to show. But here, this is basically an ion, and it's a negative ion. It has got 2 negative charge. It means it has got 2 extra electrons. Because it has got a charge of -2, it means it has got 2 extra negative electrons, 2 extra electrons. So the total number of electrons that I need to show are 24. Right? This is what the step number 2 was talking about. That if we had iron, then we need to adjust the number of valence electrons to be shown. If we had a positive charge here, then we would reduce the number of electrons from here. So 24 is the number of electrons that we need to show. Now we need to first draw a skeletal. So we see that carbon would be at the center. Let's give it a go. Carbon at the center. Then we got 3 oxygens. So I'll place oxygens like this, and I'll connect them with at least 1 pair of electrons. So basically there is a single bond between carbon and each of the oxygens. So out of 24, I have used 6 electrons. So minus 6, I need to still, so 18 electrons. So I can, these 18 electrons, and each of these oxygens are already got 2 electrons there. So to complete octet on each of these oxygens, I just need 6 electrons. So out of these 18, I can give 6 to each of these oxygen atoms. Let's do this. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now all my 24 electrons are used up, and my oxygen has got an octet. This oxygen has got an octet. That oxygen has got an octet. But the problem is the carbon now. This carbon does not have an octet. Carbon has got, if you look at this, carbon has got only 6 electrons. So carbon needs 1 more pair of electrons to gain the full octet. What we do? Very simple. What we will do exactly what we did in the previous example. One of these lone pairs on oxygens maybe this one or that one or that one or that one or that one, any one of them will convert into a shared electron. So basically, oh god, okay, so let me draw them again. So any one of these pairs will convert from lone pair to shared electron. So I'll convert this one. I removed that that lone pair from here and made that a shared pair of electrons. So now, okay, made a mistake there, not drawn properly. So that's one oxygen, that's another oxygen, that's another oxygen. So that's what we have here. All atoms have a full octet in the valence shell, and I see that total 24 number of electrons have been used. So structural diagram for this would be, for carbonate ion would be this. Then we need to show that there is a negative charge here on this. In reality, now we see that we have shown double bond with any one of the oxygen atoms here. In reality, what happens is that there is a resonance structure there, the resonance between different three atoms, oxygen atoms here. But we are not going to talk about that. And for our purpose, this is the structural diagram of carbonate ion, and that is the structural diagram, that is the electron dot diagram of carbonate ion. And that's where we are going to stop today. We got a few questions, practice questions here. I would suggest that you try them on your own.